All right, let's try the first example here. We're going to calculate the area for the region under the curve. And our curve here is given by the function f of x equal to 3 over x plus e to the x. And we're looking from x equals 1 to x equals 2. All right, so first of all, let's get a little picture of what this region looks like. So here's the graph of our function, f of x. And we're looking from x equals 1 to x equals 2. So from x equals 1 to x equals 2, when we say the area under the curve, we're really looking at this region right here. So we're going, the top section is part of our function, part of the graph of our function, and then the left side is a vertical line, the right side is a vertical line, and then we're going down to the x-axis. So we're actually calculating the area for this shaded region. All right, so one thing to note is this function, 3 over x plus e to the x, is continuous and non-negative on the interval from 1 to 2. So, it's continuous because 3 divided by x, there's no division by 0 on this interval. And e to the x is always continuous. And then non-negative, well, on this interval, the x values are positive. So 3 over x is positive, and exponential function e to the x is positive as well. So we're adding two positive numbers, so we get a positive. Another way to think of it, to see that it's non-negative, is we have the graph here, and the graph is above the x-axis. All right, so we want to calculate the area. So the area is the definite integral, the integral from 1 to 2 of our function 3 over x plus e to the x. All right, so let's just do this definite integral. So what's the antiderivative of 3 over x? Well, that's just 3 times the natural log of absolute value x. And then what's the antiderivative of e to the x? Well, that's just e to the x. And we're going to evaluate this whole thing from x equals 1 to x equals 2. If you didn't see going from 3 over x to this 3 times natural log absolute value x, maybe it's helpful to write this as 3 times 1 over x. And then we're getting the antiderivative of 1 over x. That's where the natural log absolute value x term comes from. All right. So in any case, we have our antiderivative, and now we just plug in. So the top number goes in first. And remember, for definite integrals, we don't need to include that plus c. It would get canceled off anyways. So the top number goes in first. So we get 3 times natural log 2. And absolute value 2 is just positive 2. So natural log 2 plus e squared. And then we're going to plug in our lower limit. So 3 times natural log 1 plus e raised to the power 1. And absolute value 1 is just positive 1. And then we subtract. And there's a little bit of simplifying we can do. Natural log of 1 is just 0. So this 3 times natural log 1 ends up just getting canceled off. So our area here is 3 times natural log 2 plus e squared minus e. And that's the area for that shaded region. So it turns out pretty remarkably that these definite integrals are really related to area calculations. And this is going to be a topic we explore over the next few lessons. All right, we're going to try another example like this. So we'll see you there.